This is demonstration number 16, part 1, from the aviation textbook, Advanced Airmanship, Book 1, Precision Flying. Using the data plot view, it flies a complete flight illustrating the pitch transition rules shown in demonstrations 9 through 14. Initially, we are at 3,000 feet and 250 knots, with a pitch attitude of 2 degrees and EPR setting of 1.04. We will enter a 200 knot climb, which will require a pitch attitude of 8 degrees and an EPR setting of 1.36. Both the pitch attitude and EPR setting will be set together because this is a changing both flight path and airspeed situation. Notice that the airspeed will stabilize at 200 knots. We will now make a precise level off at 15,000 feet. Using the appropriate lead, we will rotate to the zero rate pitch attitude of 4 degrees to capture 15,000 feet. We will maintain climb EPR in order to accelerate. Now that the altitude is captured, we must coordinate a pitch attitude decrease with increasing airspeed in order to maintain a constant altitude. As we approach 250 knots, we'll have to set the EPR to 1.09 in order to maintain a constant airspeed. Now we will accelerate to 340 knots. We first set the EPR to 1.30, and since this is a constant flight path maneuver, we will coordinate pitch attitude changes with airspeed changes. As we approach our target airspeed of 340 knots, we'll set the EPR to 1.12 in order to maintain a constant speed. Now we will decelerate to 300 knots. We first set the EPR to 1.05 and then coordinate a pitch increase with decreasing speed. Approaching 300 knots will increase the EPR to 1.11 to maintain 300. Now we will enter a 1,000 foot per minute descent, maintaining the speed at 300 knots. Since this is a constant speed maneuver, we will coordinate pitch changes with power changes. We now set minus 0.6 degrees and APR 1.01. Notice that the airspeed remains at 300 knots while the flight path stabilizes at 1,000 feet a minute. Next, we will level off at 13,000 feet at the same 300 knots. And again, since this is a constant airspeed maneuver, we will coordinate pitch changes with power changes. We will use the experimentally determined altitude lead of 17 feet. We will now enter a 240 knot idle descent. Since we are changing both flight path and airspeed together, we will set pitch attitude and power together. We now set the pitch attitude of 0.5 degrees and idle thrust. Notice that the target airspeed of 240 knots and the target vertical speed of 1,000 feet a minute are approached at the same time. After making a slight pitch change due to altitude effects, we will now level off at 7,000 feet. In this case, we will level off and slow down to 210 knots. So using a 24-foot altitude lead, we'll rotate to 2.6 degrees to capture 7,000 feet. As the altitude is captured, we must increase pitch attitude with decreasing airspeed in order to maintain altitude. And as we approach our target speed of 210 knots, we'll set the APR to 1.05 in order to maintain the airspeed constant. Since these pitch transition rules are based on the laws of physics, unwanted errors will occur if they are not followed.